We're here with Dr. Tom Wagner, a cryospheric scientist with NASA. Dr. Wagner, Operation IceBridge has scientists flying over the Arctic this spring. Why are the poles so important to Earth's health?
The poles are important for a few reasons. The most important is this. Changes at the poles profoundly affect the climate on the whole rest of the planet. And what people need to realize, the planet is one big interconnected system. As you lose ice from the poles, you wind up with dark ocean water exposed, which absorbs sunlight and it continues the heating up of the ocean that's already going on today. Also, too, if you're interested in sea level rise around the planet, the poles are where the majority of the ice is. And as that ice melts and goes into the ocean, it raises sea level. And about a half of the tenth of an inch a year sea level rise we see now comes from polar ice.
Why do we study this with planes and not satellites?
Planes and satellites are complementary tools for studying it. Satellites give us this bird's eye reconnaissance view of the whole planet. And they're actually the things that we use to figure out that the ice was actually melting and changing. What we're doing though now is we're following up with detailed studies with aircraft. And what we can do with planes too, we can do different things we can't do by satellites. One of the most important things is we can use ice penetrating radar to map not just the surfaces of the ice, but also to map the bed that's underneath it. On top of that too, one of the most important questions for us is how thick is the ice and how is that thickness changing? And for that we use LiDAR on the aircraft, and we do detailed studies of how glaciers in Greenland flow and draw down, and also how are changes in the thickness of the Arctic sea ice occurring, and how is that correlated with changes in the ocean.
Well, the sea ice in the Arctic grows thicker and returns during the winter. How is the ice faring this season?
Right. Well, what happens is this. Every year the ice grows out to about maybe 2 times the size of the continental US. It used to be that that ice would melt back every year to about the size of the continental US. Now it's melting back to less than half the size of the US. And so what we're trying, and on top of that, it's thinner now than it's ever been. And this year it looks like we're heading towards another one of those record lows. But what's important is this. We need to understand how that ice is connected to the ocean and the atmosphere so we can do better projections on it. And what we do with IceBridge is we do the detailed work that will allow us to do that.
IceBridge isn't just looking at sea ice, but glaciers too. Why are they important to study?
Glaciers, which is ice that is up on land, are really important for us to study because as that ice melts or it flows into the sea, it raises sea level directly. There are places in Greenland where the glaciers flow at up to 100 feet per day. Right? They're already contributing to sea level rise. What we're worried about is that those glaciers could speed up in a warming world. And so what we're doing is we're going out and mapping them with every tool that we can to get a better handle on these processes.
Each successive IceBridge campaign has broadened in scope. What's new this year?
We're doing a couple of new things this year. First thing is we're going to a bunch of important glaciers and ice caps in northern Canada. Those are also really important contributors to sea level rise, and they appear to be undergoing really rapid change right now. We're losing a lot of ice from them. The other thing is because of our altimetry measurements, literally LiDAR or lasers in the plane that tell us how high the ice is, we've realized how important those measurements are, so we're sending a second aircraft this year that's going to do a lot of detailed flight lines over Greenland.
Can you tell us a little bit more about what's it like for this airborne campaign to be up there in the Arctic?
Yeah, well, first thing, there's a lot of long hours because what you do is you get up really, really early in the morning and you report to the hangar and you try to see if the weather is safe enough for you to fly that day. And if the weather is safe enough to fly, you go and get into this airplane, which is this astounding beast filled with all kinds of the most fascinating scientific gear you could imagine. And then you get on a really noisy flight and you go fly for 8 hours over places like the sea ice or over the interior of the Greenland ice sheet. You see some fantastic sights. You know, over the sea ice, if you're lucky, you're going to see big cracks and things moving around. Maybe you'll get really lucky and see some wildlife, see some seals or, you know, things like whales and polar bears. If you're flying over Greenland, you know, you're going to see these coastal areas where you've got these rivers of ice meeting the ocean, and you're going to see rock that's some of the oldest rocks on planet Earth, billions of years old. And it's a lot of hard work, but for the scientists who do it, we really enjoy it.
Well, thanks, Dr. Wagner, and good luck with this year's mission.
Thank you.